Hey everybody, so this is the 2010 AP Free Response question number 5. So we're given this graph of G prime, which is made up of a semicircle and three line segments. G is defined and differentiable on the closed interval from -7 to 5 and satisfies G of 0 equals 5. So that's going to be important, especially for this first part that we're going to actually do. So part A asks us to find g of 3 and g of -2. So something you have to remember is if we're given a graph of g prime and we're asked to find any values on the original function, g of x, I'm going to go ahead and write this up here, then g of x is going to have to equal some initial condition plus the integral of g prime. And remember, whatever the x value is for the initial, which in this case is 0, that's going to be where our integral starts, and our integral will stop at whatever x value we're trying to find. So to find g of 3, we're going to have to actually do that. So g of 3 is going to be the initial, which is g of 0, plus the integral from 0 to 3 of g prime of x dx. Sorry, that was a really bad x. Okay, so g of 0 is equal to 5. And then the integral from 0 to 3 of g prime of x really just means what's the area. So if we look at our graph here, to go from 0 to 3, we're going to be looking at this quarter of a circle and then this triangle. So a quarter of a circle means we're going to do pi times the radius, which is 2 squared, over 4, and then plus 1/2. The base is 1 and the height is 3. So if we look at g of 3, then to simplify, we would get 5 plus pi plus 3 over 2. And so we get that g of 3 is actually equal to 13 over 2 plus pi. Okay, that's a really bad 3, so I'm going to fix that, sorry. Okay, 13 over 2 plus pi, so that's g of 3. And then if we want to do g of -2, it's very similar. So g of -2 is going to be g of 0 plus the integral from 0 to -2 of g prime. Well, g of 0 is still 5, but now if we're doing an integral from 0 to -2, we're going backwards. So that's going to be a negative area, which means I'm going to make it 5 minus, and we're going to look at the integral from 0 to -2. So that means we're looking at this quarter of a circle right there. So that's going to again be pi times 2 squared over 4. And so when we simplify everything down, we get that g of -2 is equal to 5 minus pi. Now for this question, this was worth 3 points total. All right, it was 1 point for if you remembered to use g of 0. So did you remember that from a graph of g prime, you have to do the initial plus the integral? And then it was a point for finding g of 3, and it was a point for finding g of -2. Okay? All right, so part B says to find the, where did my black one go? Um, Sorry about that. Okay, so find the point of inflection of the graph. So points of inflection mean that we're going to be looking for where g double prime changes sign. But since we don't know anything about g double prime, we're actually going to be looking at the slope of g prime. So let's take a look at our graph. I'm going to go ahead and erase the coloring that we've got going on there. And let's go ahead and highlight some stuff. We can see that the slope of g prime is positive along these intervals, and it's negative along these intervals. So that means then if we're looking for where the slope changes sign, it would be here at 0, here at 2, and here at 3. And we can see that at 0 and 3, the slope is changing from positive to negative. And then at 2, the slope is changing from negative to positive. So that's all we're going to go ahead and write then for part B. So G has points of inflection at x equals 0 and 3 because the slope of G prime changes from positive to negative at these values, and at x equals 2 because the slope of G prime changes from negative to positive at x equals 2. All right, for this question, this was worth 2 points. So it was 1 point for actually identifying all three, so 0, 2, and 3. And it's 1 point overall for your explanation. All right, and on to part C. This part is a little tricky, so you're going to have to bear with me. So the function h is defined by g of x minus 1 half x squared. Find the x coordinate of each critical point and classify it as either a relative min, relative max, or neither. So in order to find critical points, we know that we need the first derivative. So we're going to need to know what h prime of x is. So h prime of x is equal to g prime of x minus, drop the 2 so we get minus just x. Critical points mean set the first derivative equal to 0. So when we solve this, we get g prime of x is equal to x. Well, in order to figure out where that happens, I'm going to look back at the graph really quick. G prime of x equals x really just means I could be looking at the line y equals x. Since this is the graph of g prime, if I were to graph g prime equals x, or y equals x, and see where they intersect, that would give me my critical values. So I'm going to start at 0, 0, and I'm going to draw the line y equals x, and it's going to go through there. I could extend it out the other way too, but we can clearly see that it's going to be underneath this graph of g prime, so I'm not going to worry about extending it out. But what we can see then is there are two places where the original graph of g prime intersects this new line of g prime that I drew in. So we're going to have critical points at x equals 3 and at x equals whatever this other x value is. Well, this other x value happens to appear on the semicircle portion. Well, a semicircle is the square root of r squared minus x squared, so it's going to be 4 minus x squared. That's the equation of g prime of x at that spot right there. And we want to know when is that equal to just plain old x. So we can go ahead and solve this now algebraically. So 4 minus x squared is equal to x squared. 4 is equal to 2x squared. So 2 is equal to x squared. And when we take the square root, we need to remember it's a plus or minus, right? However, we're only looking at this positive x value, so the other critical point that we're going to be looking at is x equals the square root of 2. Now, in order to determine whether these critical points are a relative min, max, or neither, we need to look at the first derivative again. We need to look at this h prime of x. So we know h prime of x is equal to g prime minus x. So if we look at this a little bit closer, there's a couple of things I want to point out really quick. So first of all, if g prime of x is greater than x, so in other words, if we do a big number minus a small number, we're going to get that h prime of x is greater than 0, right? We can get that it's going to be positive. If g prime of x is less than x, so if we take a small number and subtract a big number, then we know that h prime of x is going to be less than 0. We're going to get a negative answer. All right, so these two things here are going to be really important as we move forward and make our sign chart for h prime of x. Okay, sorry, we don't need equals there. We're just going to make our sign chart. Okay, so we know that our interval is starting at -7. We have a critical point at the square root of 2. We have another critical point at 3. And then we have an end point at, what is that, x equals 5. Oh, I just erased the whole thing. That wasn't what I meant. Okay, there we go. So now we're going to need to figure out on these intervals, is g prime greater than x or is g prime less than x? So we're going to go back and look at our lines again, or at our graphs again. So between -7 and the square root of 2, we're really looking at this entire piece of the graph right here. Well, that yellow portion that I just highlighted is above the green line. Even if I were to extend the green line going the other direction to keep going with my line, there we go, then we can see it's still, the yellow portion is still above the green line, which means g prime of x is greater than x. So if g prime is greater than x, we know h prime of x is greater than 0. So h prime of x is positive along that interval. Then let's look at the next portion here. Let's do this one. Okay, so if we look, now we need to go between the square root of 2 and 3. So we're looking at this portion right here that I just highlighted in blue. That portion there that I highlighted in blue is part of g prime. G prime is underneath the line y equals x, which means then that g prime is less than x. If g prime is less than x, I know that my h prime is going to be less than 0. It's going to be negative. And then finally, one more thing to look at, one more interval. We're going to be looking from 3 to 5. And from 3 to 5, I'm going to highlight in a different color. From 3 to 5, we can see that we're underneath the line y equals x again. G prime is less than x. So if g prime is less than x, we know that h prime is going to be less than 0. All right, so now if we look, we've got this sign chart figured out. So since h prime is positive on this first interval, it means that h is increasing. And then at the square root of 2, h decides to, well, not decides, h ends up being negative, or I'm sorry, decreasing because h prime is negative. And h prime is negative from 3 to 5, which again means that h prime was negative, excuse me, so h itself was decreasing. Sorry, I'm mixing up all my variables and everything else here. So what this means then is h has a relative max at x equals the square root of 2 because h prime changes from positive to negative at x equals the square root of 2. And then if we look at 3, h prime doesn't change signs, so h has neither a min or a max. At x equals 3 because h prime does not change signs. At x equals 3. All right, So I know that's a little weird on how we kind of explained it, but hopefully that makes sense graphically looking at what's going on. We're just looking for really where g prime is either greater than x or less than x in order to determine the sign on h prime. All right, in terms of points for this one, this was worth 4 points. So, oh, sorry. It was 1 point for actually finding h prime of x. It was 1 point for getting that x equals 3 and x equals the square root of 2. And then it was 2 points for your explanations, one for each critical value that you were given. All right, hopefully that makes sense. If you have any questions, feel free to reach out and email me, okay? Thanks for watching.